Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, longest palindromic subsequence. So basically we have a string S and we want to find the longest palindromic subsequence in S. So subsequence means we can skip letters, and then we want palindromic, which means basically it reads the same forward and backwards, right? So what's, for example, if we take a look at this one, what's the longest palindromic subsequence? Well, this one here, because BBB can read the same like this and like this. If you reverse the string, it will be equal to the string itself. Okay, so and that's the longest one. So is that the longest one? No, because actually we can do better. We can take all three here, skip A, take this one, and that way it would be the same. Reverse it and string itself. Okay, and so the length of that one is 4, so we return 4. For this second one, it's only these two that can be a palindrome, and so we return 2. So that's the idea. Now the length of the string can be up to 1000, so it's reasonable, and we have only lowercase letters. Okay, so let's see how we can handle it. Okay, so how do we handle this? Well, the first observation we should make is, let's say, for example, if I have a substring like this, maybe X, maybe some characters here actually. Let's just not any characters, and then maybe I have another A here. Okay. For this string to be palindrome, we need this one and this one to be equal. Let's say if these were X and Y, just to represent some characters, these two characters need to be equal for any subsequence that starts here and ends here. These two need to be equal for it to be a palindrome, because what is a palindrome really? A palindrome, if you have 1 1 1 1, like this, maybe like this, 1 2 3 4 5, you need 5 to be equal to 1, 4 to be equal to 2, and since 3 in the middle, it doesn't need to be equal to anything, but it would be equal to itself if you sort of 0 1 2 3 4, if you sort of do that I and n minus, so n here is 5, n minus I minus 1 need to be equal. So 0 and 5 minus 0 minus 1 is 4. So every I needs to be equal to its reflection on the other side. So n minus I minus 1. So that has to happen. Even if it's, let's say you have substring here in your string, and then you have A, and then you have some strings here, and then you have A, substring here. For any subsequence that, let's say this one is index I and this one index J, for any subsequence that includes I and J to be a palindrome, you need S of I to be equal to S of J. Okay, so that's the main insight that we can go from and try to construct a solution. Okay, so now the other thing is that there is really no way to predict that a subsequence will be a palindrome or not, and there is no greedy way to sort of determine a longest one. And so what that tells us is, we can't think of a greedy approach, right? And so let's think about then trying all possibilities. That's trying all subsequence and checking if they are palindrome, and then if they are, we just add the length. Now, for a string like this, once we determine that S of I is equal to S of J, what do we know from that? Well, we know that at least we have a subsequence of length 2, because we could just take these two, because subsequence can skip letters. So we know that we can do +2 to whatever this one is. If this one is not a palindrome and maybe it's like BCD, then the substring will add 0. But if this one is a palindrome, like maybe BAB, then we know it will add 3. And so here it would be whatever is the longest subsequence in that, let's call it, what is this one? This is I plus 1 and this is J minus 1. On I plus 1 and J minus 1 plus 2, right? That's what we would have here. So from this idea, we can sort of do a recursion approach and try to solve it. Okay, so we know if s of I is equal to s of j, we know we will do this. Now, what if it's not equal? Well, if it's not equal, we don't have any information, and so let's just try both of them. What does that mean? So let me show you here. So let's go back to I and j. So let's say they are not equal, so we have b here. So what should we do in that case? Well, we should just try possibilities. What are the possibilities? Well, one possibility is that we start here and ending here. So maybe there is an A here. Maybe that's a palindrome. The other possibility is maybe it's from here to here, right? And then when we recurse, maybe this is not the right one and it's just here. And so we recurse again. But for the first recursive step, it's just one of the two, either skipping I or skipping j. You may say, why not skip to I plus 2? But if we do it in a recursion way, I plus 2 will be the next iteration for this red part, this red portion. Okay, so we only need to do it for I plus 1 j and I j minus 1. Okay, so what this means is that this is going to be just the max of trying I plus 1 j and trying the other part which ends here, which is j minus 1. So I j minus 1. Okay, so let's code up what we saw in the overview and make sure it passes. So we said we need we just have a recursive function that we can use, but for that recursive function we need just the left and the right side. Let's call them I and j. And so we need our helper function here, and we pass it I and j. I is the left side, j is the right side. And so from where do we want to start? Well, we want the longest palindromic subsequence in the entire string. So we should start from do the entire string range, because each time we will reduce j and advance I. So we should do a 0 to n minus 1 and be in the length of the string. So let's just clear that up here. 0 and n minus 1. Okay. And this would be the longest like this. And this is what we return at the end. We will calculate the max. Now, what are our base cases? Well, one base case if the two characters reach each other. So let's say, for example, here, if we advance, let's say from 0 to n minus 1, so I starts out here, j starts out here. If we advance and they reach each other on one character, let's say b, then what's the b alone is palindromic substring, and so the length is 1, and so we should return 1. Now, what if we advance like I minus 1 and then I minus 2, and then let's say it can happen in a even length, so I j. If we advance, they can just skip each other and not meet at a point. So in that case, what should be returned? Well, that means that's an empty string, because there is nothing in between if they cross each other, because we are looking for only a string from I to j. And so in that case, we want to return 0. So return 0. Okay, what else? Now that we've done this, we can just do the recursive two functions that we saw in the overview. So what's the condition is if the left and the right side are equal, then we know we at least have a length 2, but we need to check if it can be bigger by just moving. So if these are equal, right, we shouldn't keep j here or a here. We should move both so that we can check this portion here. And so we move I like this and move j like this. And so we check this portion. And so that's why here we'll do I plus 1 and j minus 1. That's the inner portion. Okay. And so we want to get the max for this substring. And so let's just call it best, start out as 0. And then here we'll take the max of that. Okay, and we will do else here. Now the else will try both possibilities. We'll try this here, and then we'll try this substring here. And so that would be just taking the max, best max of first side, which is I plus 1 to j, so just this one, or the second option, which is I to j minus 1, like this. And so that would be longest of I and j minus 1, and that should be it. And then at the end, this function, this helper function, should return the best for that subsequence from I to j. So we return best. Okay, we just need the length. So let me actually just do length of s here. Okay, looks reasonable. It will probably fail with time limit because we do 2 to the power of 3 here with these 3 function calls, and so there will be repetitions. And so for these repetitions, so time limit exceeded, we could try to do a memoization and see if that will help. It may not help, and so if it doesn't help, we can convert this one to a dynamic programming solution. And so here we want to just check if I and j are already in our memo hash map, then we can just return them like this, because we already calculated them, so no need to recalculate. And then if they are not, then here we can assign it and return it. Okay, and hopefully with this the time would be better, but let's see if it does get accepted, right? So you can see it does get accepted with that. Now, if you want to change this a little bit to a dynamic programming solution for it to be faster, what should we do? Well, let's just, so dynamic programming, we will need our base case, our state and our base case. So what is our state? Well, we want the longest, each time here from this longest, we can just look at the state here. We want the longest from I to j, so longest palindrome subsequence for subsequence I to j. Okay, or for s from I to j. And so we know that for any single character, it's 1. So for any I, dp of ii is going to be 1. Now, the most important thing for dynamic programming is to come up with your recurrence relation, right? So what's the recurrence relation here? Well, we can actually just sort of use this function, but convert it to a dp format. And so what it's going to be is ij, and just going to be the max of what we have so far. But here, since it's the first one, we have nothing. And so it's going to be if, of course, this happens only if si is equal to sj. So if that's the case, then it's going to be just the dp of, what is this one? I plus 1, right? j minus 1. Plus 2. Exact same like representation, just instead of doing the recursive function, we'll use the table. Now, otherwise, dp of ij is going to need to be the max of these two. And so what's that? So it's going to be the max of dp of I plus 1 j, and then dp of ij minus 1. Okay, so that's exact same representation, except instead of doing a recursive function, we'll save it in a table. So that so that would be equivalent to memoization, because we won't calculate the same thing twice, and so it will be something like this. Now the second piece of this is, how should we iterate? Here it was easy to know how to iterate because it's recursive. Now here, what should be the for loop for I, and what should be the for loop for j that we can do that will work here? Now for that loop to work, we need when we are calculating dp of ij, we need to have the state for I plus 1 and j minus 1. And so what this tells us is, for I, when we are calculating I, we need to know the state of I plus 1. Now, what does that tell us? That tells us that we need to go backwards from the right, because let's say we are at I equal to 2. To have the state for I equal to 3, we need to have went from 3 to 2, so we need to go backwards. And so this tells us that here this needs to be the range backwards, so from n being the length, -1 to -1, right, until we reach 0. And of course, since dp of I is equal to dp of ii is equal to 1, we can do that here. Now, what about j? Well, j here tells you that when you are at j, we need to know j minus 1. Same here and here. Okay? And so what this tells us is that for j, we needed to go forward, because when we are calculating for j equal to 4, we need to know for j equal to 3. When we are calculating for j equal to 2, we need to know for j equal to 1, right? And so what this tells us is that we need this to be up to n going forward. But what should be here? Well, remember we did I bigger than j, we return. So we want I to always be smaller or equal to j, because if it's bigger, then that's not a valid subsequence. It's not a valid subsequence from I to j. And so we need j to always be bigger than I. And so for it to be a valid subsequence, right? Because we already calculated for one letter, so we need it to be bigger. And so we do I plus 1 here. Okay. And so that should be pretty much it. Now, what should we return at the end? Well, at the end, we should just, we want the longest palindromic subsequence from 0 to n minus 1 for the entire string. And so to do that, we can just do dp of 0 and minus 1. And that's pretty much it. That's all we need for dp, is the base case, the recurrence relation, and then the order of iteration, which means basically how we set up our for loops. And so let's actually just use this then. So what we need is this here, and can return that. We also need to define the array itself, but that should be easy. That should be just in range of n, and want it for I and j, so each of them go up to n. So that would be like this. We need to define n, which is just the length of the string. And then at the end, we said we want to return for the entire string, so dp of 0 and n minus 1. For on this, looks like we're just missing this. And close parentheses, and then this one is extra. Let's submit. And that passes our test cases. Yeah, so that's pretty much it for this problem. Now, in terms of time complexity here for this, we are doing an O(n) loop, another O(n) loop, so O(n) squared here. And then in terms of space, we are using this dp array, which is O(n) squared as well. And so overall, we have only 1,000, and so this should be, yeah, pretty fast, because it's just 1,000 to the power of 2. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.